Hi everyone, and welcome to my session about optimizing for the cloud, lightning speed.NET applications and containers. My name is Martin. I am a senior consultant at Tietoevry based in Vienna. And if you have any questions that occur during the talk, please do shoot me a DM on Twitter. Also, make sure you use Stack Overflow to get your questions answered and contribute to the knowledge that we all depend upon. So what I want to do with you today is talk a bit about the axis of optimization that we can do in .NET. I want to demo you some fancy features in .NET and give you some practical recommendations what you can do with your apps to improve your performance. I hope there should be one thing that everyone could take away with for their own applications. I will mention that at the time. So what I typically run into when optimizing for the cloud is the difference between, do I choose to put some work into my app, like put in the effort to improve my application, or do I just pay more to get a higher tier when I use platform as a service components? So there's no right decision, there's always a trade-off. However, especially when we're moving into serverless compute, we really get billed for the CPU time that we use. So once we have higher and higher throughputs, maybe I want to lower my bill a little bit by improving my application. And there are some certain costs associated with that, and some of them incur during running, so when I process the throughput that's coming in, but also once I hit unjitted paths, things that have not been called before, they might slow down a particular request. Cost for .NET Startup is also considerable. There are some mitigations using like warm-up functions, but still first request latency is usually a very, very high concern in .NET. I personally also like to work with Kubernetes a lot. There are a few things that matter for these use cases specifically. First of all, for me, container size really does matter, especially when you're pulling images across different regions, or for example, when you use Azure Arc to run services on Kubernetes on on-premise clusters. So I really want to make sure that the containers are as small as possible and also as resource efficient as possible. So in Kubernetes, we usually set requests, but also limits for the CPU that we use. But then the question arises, can I actually run efficiently with maybe just a quarter of a CPU core? Especially when working with dense environments where maybe for one node, I want to run 20 to 30 different containers on them. Does it work if I run 20 .NET apps side by side? So these are the things that matter in those scenarios. And when I move to certain tools that maybe are .NET applications that perform one-off tasks that I maybe run every 15 minutes, if 90% of the runtime is just startup, like jitting and starting all the application services, which may or may not use a lot of reflection, that's maybe a bit of an overhead to just do for that time. And in Kubernetes, there's also like a philosophical discussion if what do I do with CPU limits? Some say, yeah, just don't set them. And when you encounter a peak, it will just have the resources available. However, if you have a bug in there or someone is hitting a costly path all the time, you might cause a denial of service of the node. In some applications, you can even stop the cluster from working when you just take all the CPU and then kubelet, and maybe also some if you run on-premise, maybe you have some control plane components running as well. They might be blocked by other things that use the CPU. If you have too high limits, again, you will compete with other processes that also have high limits, and the output of the behavior of the whole system might become unpredictable. But if you set the limits too low, yeah, you get predictable performance, but especially in .NET, the startup time is going to be horrible. So I've seen where just reducing to like half a CPU or a quarter of a CPU creates increases in 1 or 2 minutes of startup time in some large applications. So what can you do for optimizing? So for throughput optimization, there are some things I can help you with, but the fundamental principle is garbage in, garbage out. Runtime and DOS optimization can't fix shady code. So do invest some time in how do you refactor your code, use performance profilers, do benchmarks for certain hot code paths to make sure you're using the best code that you can write. There are also some new APIs, which I encourage you to look into, like span-based APIs if you're working with custom data formats, but also a lot of APIs in .NET are now using these span-based APIs behind the scenes. If you're doing async stuff, maybe look into value task. And if you're doing calculation-intensive tasks, maybe look into hardware accelerations using the like vector of t-based types. But if you're crazy like me, sometimes you can get down to even using the hardware instructions directly, since .NET makes them available to you. But what else can you do? First of all, stay on the latest .NET. Like, there are improvements in every version. Like, .NET 7 has been a great release, lots of performance improvements. .NET 8 looks equally promising. And if you just use the latest base class libraries, you get all these improvements for free. Also, there are new code generator features in .NET 6 and 7, which reduce the reliance on reflection and replace them with generating source at compile time. So if you're doing JSON serialization, you can basically remove all the overhead of doing the reflection and runtime code generation for the serialization logic. And of course, there are other great runtime features that I will show you in a bit. First of all, tiered compilation has been on since .NET 3, but there is a way to improve upon that using dynamic profile-guided optimization, which is opt-in in recent .NET versions. I'm going to show you a demo later on. If you really wanted to get into the nitty-gritty details, there are also settings for how does threading behave in .NET, and also how the garbage collector behaves. So apart from choosing between different garbage collectors, you can also set a lot of these customization parameters yourself. I usually rely on the .NET team making the best decisions for me, since they put a lot of effort in optimizing for resource-constrained containers. We can also pre-check .NET code. So maybe if you've been using .NET Framework applications for a while, you might remember Ngen, where you have native image generators. You install your .NET app, you run Ngen, or it is run automatically during an install process, and it will pre-generate the machine code that's going to be executed for your specific machine. In .NET Core, .NET 5, 6, 7, and so on, we have this as the ready-to-run format. So there is a tool in the .NET toolchain called CrossGen2 that can generate these ready-to-run assemblies, which are basically assemblies that have as extra metadata the machine code instructions that can be used for a specific platform. You can use this in .NET by, when you publish, setting publish ready to run to true. You can also set publish ready to run composite to true or false, which gives you some additional optimizations. So you can do like cross-assembly compiling. If you're shipping assemblies together, like a self-contained application, you can make sure that you do all the optimizations across the assembly. So for example, inlining methods from one assembly into the code of another assembly, which is only possible if you do these optimizations all at once. But there is, of course, significant overheads. So you might have compile time overheads, and the binary size increases a bit. A feature in .NET that has been there for a while is also tiered compilation. So tiered compilation actually compiles your code multiple times. The first time it does so, it does a really sloppy job. However, it is fast. So it doesn't run a lot of optimization. It doesn't look into what it could do to your code to make it faster. It just spits out the most basic machine code that it thinks is okay, and that will run fast. So for a lot of things that run during startup that only are run once or a couple of times, that is actually faster than doing the optimization up front, because the code will only be run maybe once. So that is usually used to reduce startup time. However, for all the hot paths that you have in your code, the JIT has actually injected some counters into the machine code so it can see how often some code is executed. And if it realizes here there are hot paths that are called a lot, it will recompile these methods with more optimizations enabled, so that you have also better code. It is on by default in .NET 3. You can experiment with seeing if there are like differences in startup time. I don't really see a reason to turn it off, but it's interesting to see that it has some knobs to twist. So for example, you can also tell it to do that for methods containing loops or not, because usually optimizing for loops, even in tier 0, might be beneficial, but maybe sometimes it's not. So just options to play with. However, improving on that, since we are recompiling code and we are also measuring it, there's a thing called profile-guided optimization. The idea is that when we run our code, we measure how the code is actually executed in production-like scenarios. So we look into, okay, I'm using interfaces, but what are the implementations that are actually used? You can also check which code paths are actually used more than maybe others. So for example, if I have a lot of if statements, maybe it can measure which branch do I usually go into. And in machine code, there's also some instruction encodings that can actually tell the CPU, yeah, if you see this, if this comparison is less than 0, jump to there. And by the way, that's extremely likely. So you can create this profile of how your application behaves. And then you can go into optimizing for that configuration. So the code that's generated is more tied to how you actually use your applications. And there's 2 ways to do that. So in classic.NET, that has been possible all the time. The .NET team has done that, but it's also possible in .NET 6, 7, and 8 through an additional tool. I will show you in a bit. You can collect traces while running the application. You can generate a profile, like the PGO information, from those collected trace files, and then recompile your application with the embedded profile information. This makes sure that your code is ready to run as best as it can on the first execution. So you can reduce startup time, you reduce first request or first execution latency, and it's very good to compile with other ahead of time techniques, like I mentioned, cross-chain 2 for ready to run. However, when you have to run your application, collect the traces, like first of all, it's very hard to get these production-like traces, but also keeping them in sync with your application is a mess. For example, if your application's changed 2 or 3 times a day. That's where dynamic PGO comes in, which is the most easy to use feature. You just say, I want my application to be faster. What does the runtime do? The runtime makes use of tiered compilation in the case. So in the tier 0 code, it generates some information to also collect these additional informations about like, what are the actual classes that are coming in? What code paths are executed? So it adds more probes into the generated tier 0 code. And then for the methods that it reaches later on, it will use this PGO data that it collected while running to create better code. So code might not be fast to begin with. There is a very small overhead for these additional probes, but that is being reduced all the time in every release. But you're working with production data. There is no back and forth while building, so no hassle with making sure you get the right trace for the thing that you want to rebuild. And you can just enable it, set one flag to true. Hopefully in .NET 8, for some workloads, it will be enabled by default. However, .NET 8 is still a bit out, so no definitive statements there. But in .NET 6 and 7 applications, you can just enable it, and your application should run a bit better. And again, I said there is one thing I want you to take away from the session, and that is please turn on this feature. So by just turning on this setting, you opt into tiered PGO, profile guide optimization, which means you will have dynamic profile guided optimization. Let me just show you a demo. So I have an application here that is quite simple and stupid. There is an interface I thing which only has one implementation. like something I would typically have in my business applications, where I have the interface just for testing, but in reality, I only have one implementation. And I have a factory interface, also with just one implementation that creates things using a concrete type. And then I have some workload functions that execute some functions, has a while loop. I wrap that into another for loop and just do some measurement and see how long that takes. If I run that now, yep, you should see how long these iterations take, but I've not been running using release mode. So if I look into these things, always release mode. So we're around 350 milliseconds. Now what can I do? I can turn on tiered PGO. I've also turned off tiered compilation. Let's enable everything that is. So this should be default. And this is a feature that's opt-in in .NET 6 and 7. So does it change? Yeah, so the first iteration is still a bit slower, but the other ones are blazingly fast. Because what it did is it looked at what is actually going into this. And for example, for this thing, it would generate some code, saying like if thing is the concrete class T, maybe execute some methods using this directly. So it skips the virtual method lookup. So this is called guarded devirtualization. So it checks, yeah, do I need to, is this the concrete type? If yes, maybe directly use the concrete type without doing the interface method lookup. So I still have some problems with that because I want my first iteration to be fast. And what I can do now is create a trace of that application. I have a cheat sheet here. So there are some environment variables I can set. The most important things is I need to disable all pre-treated code. I need to enable profile-guided optimization, but I also want to enable tracing for specific event pipe configurations. So if I run the executable here, okay, the first one was really, really slow, but I got a trace.net trace file out of that. So if I just copy that, I can now use a tool called .NET PGO, which gives me some options to deal with performance data. And what I want to do is I want to create an MIBC file, which is like a file that I can use to tell the compiler how my code is going to be executed. I can create this from a trace. So I use the trace file as an input. And actually, I need to do this in another directory. So .NET PGO create C from the trace that I just collected. So I now have this MIBC file. I can actually also create a dump so that I can have some human readable input. So for example, for some IL offset, it collected a histogram of the types that are passed in, and it says, yeah, always the concrete class thing, for example, is used here. And also only the factory implementation is used. So I can now tell my application that I have some ready to run file that it can use. And if I publish now again, I can have to publish for a specific runtime because I want to pre-compile my code. Not self-contained. And I want to set publish ready to run to true. So I should be in here. Perfect. So the first iteration is quite fast, but it gets worse at the end. And that's because that PGO information is actually lost. .NET 8 will make some improvements here because the optimized code is actually treated as a tier 0 code. So the runtime might decide to reject the code, but for the rejecting, it will not have the performance data. That might change in .NET 8. However, there is a way to work around this because I can also get an additional argument to this cross-gen 2 application that generates this precompiled code and tell it, yeah, by the way, the PGO data that I gave you also embedded into the binary that's created. So if I publish that again, I should now have an application that is starting up fast and is running fast all the way through. So that's a way to use this feature. However, if you don't want to go through all this trouble, again, just enable tiered PGO. So what else can you do? So size-wise, there is a feature called trimming. This reduces the size of self-contained applications. So if you're publishing the application and you want to, for example, do a single file self-contained publish, it's going to be around like 70 to 80 megabytes at the minimum. But you can trim that by removing all the code that's not needed. So it shakes your code and everything that's not tied to a specific root will just fall off. You can tell it which assemblies are your root assemblies. You can also create some XML descriptors to tell it, hey, of this assembly, keep this and this type and this methods and these properties. But there are some limitations to that approach. First of all, dynamic code can be problematic. So if you're the thing that you're using is not referenced directly in the C# code that you write, it might get trimmed away. And then if you use reflection to look at the types, for example, in serialization use cases, a property might just be gone. Or for example, you're only using the getter, you're never calling the setter, yet then the setter will be gone. And if you try to set the property via reflection, you can no longer do that. There's also no support for COM. There are these are new features called COM wrappers that can help here. But if you're using COM directly, that might not work. That's also the reason why WinForms applications can currently not use trimming, because not everything in there is already converted to these COM wrappers. I hope that's about to change in the upcoming releases. And WPF makes very heavy use of reflection and runtime code inspection. So you're going to have a hard time trimming your WPF applications. It can be possible if you specify everything you need to keep, but it's very hard to do. Of course, there's some reflection limitations. As I mentioned, properties might be gone, setters might be gone. Here you can use the source generator that I mentioned earlier that generates all the serialization logic for you behind the scenes. And you can reuse that, and trimming will keep everything that's used in this generated source code. Dynamic assembly loading, again, if you trim away DLLs that are not used, your plugins might be gone if you have a plugin architecture. So the trimmer will not see an instantiation, for example, of a class of an interface or implementation of an interface that's only done via reflection or by dynamically loaded assembly. So that might just be gone. There are ways to deal with that. So a couple of different attributes that you can put on certain variables or parameters or methods to tell the linker exactly how your methods behave, or if some methods really rely on some things that don't work in trimming. And if someone uses your library and calls it methods, they will get a warning. I'll show you some of them in a bit. If you're writing libraries, internal libraries, but also public libraries, you can get ready for this by enabling the trim analysis in your project files. So this will give you all the warnings that someone would see that is publishing an application and trimming it. So you can make sure that you're annotating your code correctly with the attributes that I mentioned. There are some guides on the Microsoft Learn website that tell you how to do this exactly, because there are a lot of special cases. And you can also mark your library as trimmable. So in .NET 6 and 7, so in .NET 7, the way of trimming changed a bit. So there is full trimming, which trims everything, and partial trimming, which only trims assemblies that are marked as is trimmable. You can set that to true if you know that your assembly is going to be trimmable. So if you set that is trimmable property in your project file, it will create an assembly metadata that tells the trimmer, yeah, this assembly is really like prepared to be trimmed. So I want to give you a small sample of that. So I have a very small application here. I hope I can get OmniSharp working, but if not, then we will have to deal with these squigglies. So if I just run this application, it will find plugins that can be used in the application. The way this works is there is a plugin interface. There are 3 different implementations. And there is a utility that through reflection helps finding implementations of this interface and give you all the plugins that are available. That works fine. But if I now want to publish my application, self-contained, maybe a single file. So I have my executable here, but it's a 66 megabyte executable for something that is not doing that much, right? It works, but really for a small tool, it's a lot. And what I can try now is set publish trimmed to true. And I can also already see like there are some warnings here because my code might not behave well. So if I check again, yeah, my library is now 11 megabytes. So still some room for optimization, but a lot smaller. However, when I run it, all my plugins are gone because they've all been trimmed away because no one really used these things. However, if I have some code in here that directly references, for example, plugin B and calls a method, then it might see, okay, it sees, yeah, there was a class that I could use, but I never created it using the constructor call, so the constructor is gone. Nothing to help here. And the way I can fix this, I can tell it, yeah, if I pass a type in here in create plugin, make sure you keep all the members of this type. So I should be able to fix this exception here. Right, so it now sees plugin B is being used, and since I pass in plugin B to the create plugin function, it knows, hey, keep everything in there. I can also specify directly that maybe calling find all plugin names, it uses plugin A and plugin B, different ways of doing that. I can also do something like create a static property that I just assign in a static constructor. Again, I'm not really using this code, I'm just writing it so that the trimmer sees it. Maybe not the cleanest thing to do, but it works. And now everything is working. So this is how you can use trimming. You can also create some like XML file that says, yeah, keep this type and these methods. which you can then also use in your project file using this trimmer root assembly item. But that's already a bit advanced for trimming. There is a reason to use it though, and that's a new feature in .NET. It has been around for a while, it has been incubated for a number of years, but it's finally moving more and more ready to production, which is native ahead of time compilation. This is a real game changer. It basically removes all the JIT stuff from the application. It fully compiles your application ahead of time. You only ship the machine code that you're going to be executing. So there is no just-in-time compiler available while running. You will get the smallest possible binary size, and it's supported for console applications in .NET 7. So if you have a tool application, provided that the libraries that you use support it, then you should be ready to go, and you should be supported in .NET 7. In .NET 8, the team is working hard to enable minimal APIs, so you can also host like web services that provide APIs using ahead-of-time compilation, which just removes a lot of the startup time overhead. But the prerequisite is that your application and libraries need to be trimmable. So you have to go through all this trimming configuration that I just showed you, and then your application should work fine with native AOT. However, you still need some native compilation tool chains. So on Windows, you might need to install the C++ workload of Visual Studio. On Linux, you need access to the platform linker, because that is used for producing the output. It's just native platform-specific code. There are some limitations. Again, there's no JIT available, so everything that does runtime code generation, reflection emit just doesn't work. And a few other limitations exist, like C++ CLIs. COM interrupt doesn't really work. You have the same restrictions as single file deployments. So working with like assembly interfaces, you might get weird results. But of course, you're just like in self-contained deployments, you're including the entire runtime, which may have servicing implications for you. So in .NET, I mentioned there is planned support for minimal web APIs. They may or may not also support the controllers model. So basically all the parts of the MVC framework that just use controllers for APIs. They will, however, not support views, Blazor, and I think EF Core is not officially supported. I've seen someone hacking all the required things through trimming to get it working. I'm not sure if that's going to be supported or not. However, the performance is just mind-blowing. So your application size reduces a lot. I think now it's even down to 7 or 8 megabytes. The memory usage drops, and the startup time is a lot faster. Let me show you. So I have this web API here. This is basically the .NET New API sample. So you have the slim builder, and there are like 2 functions that where you can use to get to-dos by ID. I can do a .NET publish here. Let's just see if it compiles. Perfect. So I want to now publish for a specific runtime, Windows in my case. And I maybe would want to create like a self-contained applications. Maybe I want to use publish trimmed and publish single file. Just to be specific, I do not expect this to run as of now. Okay, messed up the single file, but you can see it's still 36 megabytes. So even trimmed, you have a lot of the framework in there. If I now try to use ahead of time compilation, I can just say publish AOT ahead of time compiled true. And now there's a new step in here. Where it says generating native code. So it uses the JIT components to generate all the machine code instructions for the .NET code that I've written. And I think it just published that in here. And it's now a 9 megabyte executable. That's pretty mind-blowing, to be honest. However, if I run that now and I click on the link, maybe I want to get to-dos, I get an exception, HTTP 500, and it says, yeah, it cannot really find serialization informations for my to-do class, and that's because, well, I haven't set up serialization, so it tries to do runtime inspection, it tries to do code generation, and none of that really works. And there is a way around that, that is by using the JSON source generator. So I can actually subclass this class called JSON serializer context with my own partial class, add some annotations of all the types that I want to use in here. Actually, this should be sufficient. And behind the scene, it will generate all the serialization logic, all the metadata that's needed while running the application. But I also need to tell it to use this context. And I can do that by configuring my HTTP JSON options. That's the one that's used for the minimal APIs. And tell those serializer options to please use the type information from this context. So let me recompile that quickly. Generating, it's thinking. Okay. Let's run it again. The startup is really fast. Like, there's even no lag in here. So if I try that again, oh, I get 404. Let's check the to-dos. Yeah, I get my JSON. Yeah, I should do the dishes. True. So that works, and it is fully ahead of time compiled. And it ended up just being a 9 megabyte executable. Again, I think in future previews, they're already down to 7 or 8 megabytes. So that's actually quite a lot. And the way I made this work now is using the source generator. I also enabled a feature that should output the compiler generated files. Yep, so the source generator generated a class, like a lot of partial extensions to that context, where I just put on a lot of these metadata information. So for example, like the properties that I have on the to-do objects, a getter and a setter method that statically reference the correct setter and getter functions. So all these are kept by trimming and then AOT compiled. There's another feature of AOT compilation that I just can't keep myself from showing you because it's awesome. And you can actually not only create applications, you can also create native libraries. The way to do this is annotating some public static methods with an attribute unmanaged callers only. So when I do ahead of time compilation of this library, I can actually use that from native code. So I'm now working in my Windows subsystem for Linux, since I'm a bit more comfortable using C++ on Linux. So I have my library, and I can actually publish the library. .NET publish release for Linux 64-bit publish AOT true. Apparently it's a demo effect. Linux x64. Generative native code. So, and I now got a .so file. If I move that to a sample application, this might be a bit larger now because it has some debug symbols. So if I want to use a library in Linux, it needs to be called lib and the library name. I have a small C code that has a forward declaration for this greeting method. So this you would typically ship in a header file to be imported by the application that uses it, and has some C code that calls into this thing. Maybe let's say global Azure. Yeah. Bootcamp. Just say global Azure. I have a script here that compiles this library, just because the current directory is usually not used for referencing libraries. So let's compile this, and I get a sample executable. And it says, hello, global Azure. So I've created a C application that just booted up the .NET runtime that the ahead of time compiled things use, and just called into my library, and it didn't have to do a lot, like no bootstrapping of the runtime, etc. So I think that's actually quite powerful. In summary, what do I want you to take away from this? So here are some recommendations, but again, without any guarantees that it might work or be good for you. So my recommendation, of course, always publish in release mode, and try to enable tiered PGO if you're running on .NET 6 and 7. Again, in .NET 8, for some workloads, this may be enabled by default. However, just put it in your project file, see if it works, see if application increases throughput. If you want to optimize for startup, look into ready to run. Publish self-contained applications, enable that feature. If you want to reduce the size as well, make sure you trim your application, and use the publish ready to run composite on that, because it's already trimmed and a lot smaller. And you should have the best startup and size that should use for most .NET applications. And if you want to get into further detail, try AOT. And with that, I would like to thank you. Please reach out to me on Twitter or LinkedIn or any other platform that I'm on if you have any questions. Unfortunately, I cannot really stick around for the online part of the interactive sessions here at the Global Azure, but I hope you had a good time, and thank you for your time.